In this example, we're asked to show that if n cubed plus 5 is odd, then n is even. So let's take a look at this as we usually do here. N cubed plus 5 is odd. This is our statement P. By the way, n has to be an integer to even talk about even and odd. So n is even, that's our Q. And the implication is going P implies Q. Now, when you look at this, if you didn't know that you were supposed to use contraposition, I mean, these notes right now are lectures on proof by contraposition, so we can kind of jump straight into it. But as you go through this problem, you want to think about why am I using proof by contraposition? And one of the reasons for this one is that n cubed plus 5 is odd. How do we translate this into math, right? Well, this means that there exists some integer k in Z such that, what's true? N cubed plus 5 is equal to 2k plus 1. Well, and then we want to try to say something about n itself, but remember, you can't just take cube roots of integers if you don't know anything about them. You're not allowed to just take the cube root of some number. For example, I mean, the cube root of n cubed is fine, but the cube root of whatever's on the right-hand side might not be fine, right? So this becomes a little problematic, and we want to try to avoid having the power of n here. All right. So instead, we can do this by contraposition. So what's the contrapositive of our given statement going to be? So contraposition here, it's obviously not Q is going to imply not P. This is what we're going to want to prove. And so this statement's going to say if Q is not even. Well, we know what that means, right? If Q is not even. If n is not even. So if n is odd, that's what it means to be not even. Then we want to prove that n cubed plus 5 is not odd. Or in other words, n cubed plus 5 must be even, right? And so this is what we'll prove. We'll start with this. So we're ready to do it, I think. I don't think there's anything else that needs to be unpacked before we start our proof. We know exactly what we're going to do here. So let's do it. Proof. Let's let n be an integer. We could just say that n is odd, right? So let's let this be odd. Then there exists an integer k, right, satisfying. So I'm unpacking the definition of odd here. N is equal to 2k plus 1. And at this point, all we have to do is plug it into the formula. We don't have to get too fancy with the English here, right? But then, what's going to be true about n cubed plus 5? Well, it's going to be 2k plus 1 quantity cubed plus 5. And if we multiply this out, let's see what happens, right? So this is going to end up being, so when you cube this, how's it going to work? So it's going to be 8k cubed plus, then there's a factor of 3 on the two middle terms, right? So this is going to be 4k squared times 3, so that's 12k squared plus, and then 2k times 3, so 6k plus 1 plus 5. All right, and at this point, remember our goal, not only is it our goal, but we know that we want to say something about even or odd for this term. So at this point, we notice that if we can combine these two constants, then we can factor a 2 out of this entire statement, right? So we can write this as 2 times, what's left? 2 times, so 2 times, what's going to be left here is 4k cubed plus 6k squared plus 3k plus 3. All right, and as usual, what's true here? Well, this number, let's call it m, is equal to 4k cubed plus 6k squared plus 3k plus 3. This number is an integer. We've used this fact a few times now, but integers are closed under multiplication, addition, and subtraction, right? So this is an integer, and what do we conclude? So whence, what? N cubed plus 5 is equal to 2m, all right? Let's make our conclusion then, right? So therefore, n cubed plus 5 is even when, or if, n is odd, by contraposition, you always have to finish off the proofs, even though you feel like you understand it, right? You have to finish it for the reader. By contraposition, we conclude. A little more room here. So we conclude that if n cubed plus 5 is even, so if n cubed plus 5 is even, then n is odd. Alright, and there is our proof by contraposition, although I got these wrong, didn't I? So this was supposed to be if n cubed plus 5 is even. I just did it again. Is odd. Sorry, right? We did contraposition. N cubed plus 5 is odd, then n must be even. Alright, and now I prematurely put the smiley face here, but now we are ready to smile. The proof is complete. We have proved this statement by contraposition.